All right. Here we have an alternating series. And this question is asking, can you think of an alternating series where if you get rid of the signs, it diverges, but if you include the signs, it converges? What's such an example? If you make it alternating, it converges, but if you make it jump only to the right, then it diverges.
Yeah.
1 over n squared.
Well, 1 over n squared, okay, negative 1 to the nth power 1 over n squared, this will be converging absolutely because even with the absolute value, it's going to converge, right? This summation is a p series with p equals to 2, so it converges, right? And because this absolute value converges, without it, it will converge as well. So in this case, this is an example where both are converging. Okay? What's a case where the absolute value version diverges? You're very close. Don't know?
That's harmonic.
Harmonic, yeah. The harmonic one will, so 1 over n, the harmonic one, okay? So we know that this one diverges. Okay. But then summation of negative 1 to the nth power of 1 over n, this converges by what test? Alternating series test. Because what are the two conditions? First, limit has to go to 0. Limit n going to infinity of a and no, not that one, sorry. A n plus 1, which is 1 over n plus 1, is less than 1 over n, which is a n. So it satisfies both conditions for the alternating series test. Therefore, this converges, whereas this doesn't. Okay? And actually, there are several other ones. Right? You could also use the square root. Right? This one also has the same property. So there are many examples you can come up with. As long as it's any p series with p less than 1 and bigger than 0. Okay? That's going to work. Yes?
What's like something that does not like apply to like the second rule? So like what's like an plus 1? When can an plus 1 be greater than an? Like an example.
So that was one of the examples that we did earlier. When this was true, but this wasn't true, where you're going back and forth, but one side is bigger than the other.
Oh, okay.
Yeah. So if it's not monotonically decreasing, then it can escape to one direction. Okay, so these examples should give you an idea of what conditionally convergent means, right? If this is true, we say it's conditionally convergent. If both are convergent, we say it's absolutely convergent.